Hello student, welcome to the 10th day of online tutorial session. Today's topic is encoder. An encoder is a digital circuit that performs the inverse operation of a decoder. Hence, the opposite of the decoding process is called encoding. An encoder is a combinational logic circuit that converts an active input signal into a coded output signals. Okay, so it has n input lines and only one of which is activated at any time and m output lines. It encoded one of the activate inputs to a coded binary output with the m bits. So in an encoder, the number of output is less than the number of input. Okay. So this is actually the block diagram for 8x3 decoder. Just the opposite of a decoder, because here it is 8x3 encoder, because previously in decoder is what 3x8, 8 is the number of output and 3 is the number of input. Encoder is just the opposite because it will convert from octal to binary. It is an octal to binary encoder. So here number of input is 8 but output is only 3. So that's why it is 8x3. Okay. So we will move forward to the truth table. So octal to binary encoder is a well-known circuit. Actually, it accepts the 3-bit input code and activates one of the 8 output lines corresponding to that code. An octal to binary encoder performs just opposite functions. It accepts 8 input and produces 3-bit output code corresponding to the activated input. From the truth table, we are able to understand that Y0, that is the first output, if you see, the first, that is X, that is, or you can say Y0 or X, will be selected when after we will clubbing the D4, D5, D6 and D7. Y output will be selected when we will combine D2, D3, D6 and D7. Z will be selected when D1, D3, D5 and D7 will be selected. Again we are going back to the truth table. Now just see, X will be selected. When X will be selected, see where position X is 1. Where X is 1, we will find out the value. Here is what? X is 1. For which term we are getting the X value? For which term? We have to find out that one. Here we are getting 1 value. When we will first getting the 1? So we are getting 1 for D1. First we are getting value for D1. You just look of the again circuit, that is D4, D5, D6 and D7. X we are getting for D4, D5, D6 and D7. So for X we are getting D5, D4. Here the X value is having 1. So where I am getting 1? Here D4, D5, D6 and D7. Okay. So we will club all this input D4, D5, D6. Okay. For Y where I am getting 1? Here. That is D2. Again here D3. Here in D6 part. Here in D7 part. For the Z where I am getting the input? Here in D1. Here in D3. Here in D5. And here in D7. So we will club all those inputs, okay, to get the X, Y and Z output lines. So to implement this circuit, what we require, here we will require only the OR gate required because here the plus operation is there, no NOT gate is required. Okay, here is 3 output lines are there, so for that reason we require only 3 OR gate. Okay, and for X we will combine only D4, D5, D6 and D7, and for Y we will take D2, D3, D6, D7, and for Z we will take D1, D3, D5 and D7. In this way we can generate our logical circuit. Thank you student. I am ending